A test coming up, so the practices are up. And now we're going to look at the nervous system PowerPoint and get a little bit ahead in an early review of these topics. Okay, so the nervous system and the endocrine system. The nervous system takes care of when we need a rapid response, when we step on a nail or we touch a hot stove, or we have pain, when we have an injury to our skin. The nervous system is going to be involved in very, very short duration events, but it allows us to keep ourselves safe and to make sure we don't freeze to death or die from hyperthermia. The endocrine system is a much slower response. So over time, growth hormone and the sex hormones will lead to, okay, we got somebody else, it'll lead to the development of a male or a female, and will lead to usually males having larger muscles, larger bones, and being generally bigger than females. So there are two divisions of the nervous system: the central nervous system and the peripheral nervous system. So the brain and the spinal cord are the CNS. The peripheral nervous system is everything else. So afferent means messages, nerve spikes, action potentials are carried from the exterior back to the spinal cord and ultimately to the brain. Efferent means action potentials, nerve spikes that cause muscles to contract and are involved in autonomic nervous system regulation. So that's motor output. Nerve activity or nerve spikes, nerve signals, action potentials leave the central nervous system to allow us to walk, to sit, and bladder control, digestive processes that allow us to eat and so on, and breathing and kidney function and all these automatic functions that take place. So we're back to the nervous system. So afferent carries information to the central nervous system. Sensory input, meaning am I cold? Do I feel pain? Do I feel pressure? Do I feel light pressure or very strong pressure? So central nervous system receives the sensory input, and that's the afferent division. The efferent division sends out signals once it's perceived these reports from the sensory receptors, and that's going to allow us to, again, to walk and to send out information that happens automatically in the autonomic nervous system. So heartbeat, blood vessel function, respiration, all these functions that are automatic that take place. Okay, so here's a diagram. The central nervous system processes information. Here's the peripheral nervous system, the afferent division. Receptors monitor the outside world. The visceral receptors monitor digestive activity, respiratory activity, also bladder activity, whether your bladder is full or not, whether you have to urinate, if you have to defecate, if your digestive system is full. Generally, we sense that the bladder is full or the digestive system is full, and we need to eliminate waste. Right now, I'm 74 years old, so I'm having a fun time. My bladder wants to empty all the time, but that's neither here nor there. It's here. So the motor component of the efferent division stimulates skeletal muscle in the autonomic nervous system with sympathetic and parasympathetic. These automatic signals processes this visceral sensory information and controls smooth muscle in the digestive tract, in blood vessels, controls the heart rate, primarily acceleration, glands, and adipose tissue. So the nervous system has neurons or nerve cells and has neuroglial cells, nerve glue. So there's a whole population of different cells that support the framework for neurons and phagocytes that will clean up dead tissue, waste from dead tissues, and also attack foreign invaders such as bacteria. So some neurons deliver information to the central nervous system. Motor neurons stimulate muscle. They can inhibit tissues also. And the connections between the sensory neurons and the motor neurons will be taken care of by interneurons. So some analysis is automatic. I mean, again, suppose you step on a nail, you immediately have an automatic reflex, and you have a reflex arc, and hopefully that'll keep you from driving a nail through your foot and just put a little hole in your bottom of your shoe. Hopefully it'll close up. But there are sensory neurons, motor neurons, interneurons. So motor neurons stimulate smooth muscle, cardiac muscle, skeletal muscle, the output from the system for us to be able to eat and travel and play sports. Those are all taken care of by the stimulation from the neurons, motor neurons, after sensory neurons have given us the position of all our limbs and joint positions. So this is all automatically taken care of, mostly by the autonomic nervous system, so that we can receive information and our body acts to keep us alive, helps us find food, helps us find drink, and so on. So a neuron is made up of a cell body, dendrites, and axons. So what does that look like? So this is a multipolar neuron. It has multiple dendrites, which allow information to be sent into the cell body. This is an axon. An axon hillock is where the nerve impulse begins. And the axon carries messages away from the cell body and, for instance, will stimulate skeletal muscle for contraction. So let's stop there and have a first video. Stop recording.